Good morning and good afternoon, everyone. Welcome to our 2025 Summer and Tropical Season Outlook webinar. My name is Andrea Berg, and I will be your host for today. Before we begin, I just want to go over a few housekeeping items. We are recording this webinar, and about 5 days after the webinar, we will send out an email to everyone who has registered a link to the recording. If you have any questions during the webinar at any time, please use the chat or the Q&A feature as part of WebEx, and we will address your questions at the end or within WebEx itself. If you're experiencing any difficulties at any time throughout the presentation, use the chat feature and to contact me, the host, and I will try and troubleshoot as best as I can. So with that, I am going to turn the presentation over to Nate.
All right, thank you, Andrea, and welcome everybody. We have a lot to get through today. Our presenters are myself, a weather risk communicator for our long range team, and the leader of our long range team, Stephen Strum. And we've been doing this a little while. We're going to bring that experience to you with this presentation. Our agenda, it will be to first go over the 2024 tropical season highlights, and there were a lot of them. So we'll go over what happened last year, and then we're going to go over the expected seasonal influence for 2025, and we'll throw some model tropical parameter forecasts into the mix, and we'll wrap that up into a DTN tropical season outlook. And I'm going to pass the baton over to Steve, who will go over the summer season. We'll go over things like the May through September outlook, cooling degree days for energy purposes, and then other things like severe weather and wildfire risks that could have an impact on you this summer. And then we'll go over specific industry impacts like the utility sector, the aviation sector, public safety, and offshore impacts. And then we'll leave some time at the end for questions. So as Andrea said, use the Q&A feature or the chat and put them in there as we go along, and we'll do our best to get answers to your questions the best that we can. So let's go over the 2024 tropical season review. And it was a busy one. We had 18 named storms, 11 of which were hurricanes. 5 of those were major hurricanes, which are defined as Category 3 or stronger storms. And the map on the right shows the track of each and every one of them. It is easy to note that the Gulf of Mexico, the Gulf of America are very busy. And we had a few storms that recurved, and we had one long track storm that came across the Caribbean and then ended up in Texas and then impacted a lot more of the eastern U.S. We had 5 U.S. named storm landfalls, and all 5 of those were hurricanes this year. So that amounted to $129.7 billion in damage, which is the 3rd costliest season on record. And our yearly tradition of starting storms, starting the hurricane season before June 1st has apparently come to an end, because this is the 3rd straight year that we have not had a storm form prior to June 1st. Let's go over some statistics overall. And named storms and hurricanes by year. So every year since 1950, we have the green bars, which are all named storms, the yellow bars, which are hurricanes, and the red bars, which are major hurricanes. And you have each one there. And then the traces that are in place are the 10-year running average. So a couple things stand out. First, the green line seems pretty steady, even goes down a little bit from the 80s, even into the 90s. And then there was a sudden increase in those storms during the late 90s and then during the 2000s all the way through. But the yellow and the red line, you don't really see much of a corresponding increase. You've had a couple very large impact seasons like 2005 and 2020, but what you don't see is a big increase in hurricanes and major hurricanes. Now, a couple things going on. Number one, we had the Atlantic Ocean warm up quite a bit starting in the 90s. So warmer ocean temperatures equals more storms. So that's part of it. But the other thing is that we've had improved satellite technology and better ways to look out there and actually detect storms. So we're able to detect more of these weaker storms today than we were able to all those years ago. So I think that's inflating the numbers a little bit as well. But some of the major storms, we always knew they were out there, and that kind of gives us a little better idea of what the trends are. So we really haven't had any real increase in the number of hurricanes and major hurricanes out there. So we'll start with Hurricane Beryl, and this one was around for a while. It started in very late June and lasted all the way through the 11th of July. Took a track all the way through the Caribbean into the Western Gulf, coming onshore at Matagorda, Texas. It did peak out as a Category 5 storm, 165-mile-per-hour sustained winds, but it did weaken as it came closer to coming onshore. It was a hurricane as it got there, but notice the track. It took a track all the way through eastern Texas and then up through the middle Mississippi Valley into the Great Lakes. So it had a lot of time to impact a lot of people. So on the bottom right there, you see the rainfall amounts that occurred with it. And the maximum amount was almost 15 inches in Thompson's, Texas. But note here, 1 to 4, 2 to 5 inches widespread along that track. And then some places were higher than that. So some flooding concerns in there. That produced $8.3 billion in damage along the way. And it produced over 2.5 million power outages in Texas, many of which happened in the Houston area. Notice the storm went to the west of Houston. That's not the place you want to be. And once it came on shore, the remnants produced 76 tornadoes from the Louisiana, eastern Texas area up to the Ohio Valley, and even in parts of upstate New York, July 8th through the 10th. Major flooding occurred in eastern Texas as a result of all that rain. The peak was, again, 14.99 inches in Thompson's, but flooding rains also extended all the way up into the adjacent states of Arkansas, Missouri, Illinois, Indiana, New York, Michigan, Vermont, New Hampshire, and even into Maine. So very, very far away from the landfall point, we had impacts. And we also had severe weather that occurred with it. Sometimes these storms can spawn tornadoes and damaging winds. And 8th, 9th, and 10th, you can watch it go all the way up into the northeast. Had a lot of tornado reports in the Arklatex region on the 8th, and then that expanded up into the Ohio Valley region on the 9th. And then upstate New York, we had a few tornadoes, and also we had a almost widespread damaging wind event that came from this. Over 150 wind reports from the 10th alone were barely related. And upstate New York saw 150,000 power outages from Beryl's remnants. So even after the storm comes onshore and weekends, it can still have a significant impact. And there was even a fatality from a tornado in Mount Vernon, Indiana, and one from damaging winds in Canastota, New York. Moving on to Hurricane Debby, that was in August 3rd to the 11th. This one took a track across the south shore of Cuba and then up through the eastern Gulf, coming into the Big Bend region of Florida, and then came offshore briefly off of the South Carolina coast and then back on before weakening as it went up through the northeast. So note the rainfall trace. There was a lot of rainfall due to that slow movement across portions of coastal South Carolina, coastal Georgia, and southeastern North Carolina. 22.2 inches of rain fell in Mox Corner, South Carolina, producing major flooding in a lot of those areas. 8 to 13 inches of widespread rain occurred in that aforementioned area. And then there were some tornadoes in parts of Florida, Georgia, and the eastern Carolinas. 18 fatalities out of that. This was just a Category 1 storm, but still had a pretty large scale impact. Then we had Hurricane Francine that originated in the Gulf and ended up coming onshore in central Louisiana and then slowly creeped up into the lower Mississippi Valley and into northern Arkansas. And even this storm, it was a Category 2 storm, 105-mile-per-hour sustained winds, $1.3 billion in damage, but a lot of flooding occurred along the path from all the way from parts of the Florida Panhandle all the way up into the Tennessee Valley. So, and then there was a 5 to 8 foot storm surge across the central Louisiana coastline. And then one of the two big ones of the season, Hurricane Helene, late September, Category 4 storm at the peak, 140-mile-per-hour sustained winds. It came onshore over the Panhandle region of Florida, it produced $78.7 billion of damage, so probably even more by the time everything's said and done. 249 total fatalities. Still 6 people are missing from this. And note here on the upper right-hand corner, there is a power outage map that goes from northern Florida all the way up through the central Appalachians. So many power outages, 4.8 million in total. It lasted for quite some time, sometimes up to a week, even more in some spots. And then storm surge peaked at 12 to 16 feet along the northern Florida west coast, and that had a lot of impact on people from Tampa northward. And historic flooding occurred with this. The southern Appalachians with the river flooding, haven't seen that since the 1910s. This caused some entire towns to be swept away from the floodwaters, and it will be a long, long time for this place is ever the same again. So a very major flooding event in near Asheville and in the areas surrounding it. Very much a high impact. It'll be an event that this region remembers for quite some time. Now, Hurricane Milton, 180 mile per hour Category 5 storm, one of the more powerful ones out there. Landfall was Siesta Key, $34.3 billion in damage, and the only place it went was Central Florida. So at 45 total fatalities, the 6 are still missing from this. Widespread rainfall amounts, 10 to 15 inches along and north of I-4 in Central Florida, with a peak at 20.4 inches in St. Petersburg, Florida. So major flooding occurred with that. And also major storm surge flooding occurred along the southwestern Florida coast, south of Tampa, north of Naples. So those areas had some major impacts from that storm. Let's go over some U.S. hurricane landfall trends, and this is from the early 1900s all the way through last year. So on the top graph, you have all hurricane landfalls, and then on the bottom graph, you have U.S. major hurricane landfalls, and this is from data from a research paper, and then that was updated through 2020, and then I just added NHC data from 2021 to 2024 to round it out. And one thing you'll see on there is we have the 10-year average and then the long-term average, and then some cyclical nature in there, but there is no increased trend for landfalling storms. Matter of fact, it looks very flat to me. There's a lot of volatility involved. Some years are pretty bad, and then some years don't have any at all. That's both major hurricanes and all hurricanes. And from about late 2006 till August 2017, there was a stretch where 0 major hurricane landfalls occurred across the U.S., and that was a record stretch. So there is some ups and downs with this stuff, but overall there hasn't been a major trend. Now, since about 2017 to 2025, major landfall hurricanes have increased. So I think we went through the down stretch, and now we're getting the payment for that to bring everything in line with historical averages. Then we'll take it a step further. Landfall trends. These are hurricane landfall trends since 1850, broken down by decade. And notice it used to happen quite a bit more than it does these days. Now it does look like 2020s are going to reverse the trend, and we're going to have quite a few more. It could be one of the bigger decades. We're on pace, 15 already, and which is the average of 17.5 landfalls per decade. So we're about ready to pass that halfway through the decade. The AMO index is plotted over in the top center. So where the index is positive in the reds, that is warm ocean water. The index is negative in the blues, that is cooler Atlantic Ocean water. So you can line that up pretty well. Cooler the water, less storms you're going to have. And it does make a difference because positive AMO does increase the odds of a landfall overall. The stats say that, especially along the eastern Florida and the east coast of the U.S. The Gulf is a separate category because the temperatures sometimes differ. Taking a look at tornadoes spawned by tropical cyclones. Tornadoes often occur along the path of tropical cyclones, and we showed this earlier with Beryl, or in rain bands. So a lot of them you'll be in the south and east flank of it. So if the tropical system goes off to your west, there's a chance you will have to deal with one of those nearby. These account for about 6% of all reported U.S. tornadoes. The map shows you where they are. Now, know how far inland they can get. All the way is Indiana, it's going to be parts of upstate New York if this were updated for last year. So just because you're not near the coast doesn't mean something bad can't happen to you because of a tropical system and well beyond the landfall point. Could even be over 1,000, 1,500 miles away, depending on the track of the system. So tornadoes, that's a big part of the impact from hurricanes. And here's the highest rainfall from a tropical cyclone. This is updated through 2023. We don't have all the data yet through last year, but it goes to show you what can happen. Notice here, Harvey was the breadwinner, 60.58 inches in 2017, but you look away from the coast, you got 12.5 inches in Kansas, even 3 inches in Idaho. So all lower 48 states can be impacted by remnant tropical systems, at least, and it can produce heavy rain. So something we have to keep an eye on no matter how far away from the coast we are. So important historical factors. No major hurricanes made landfall between October 05 and August 2017. That's a record span. And ever since then, we had 11 of them occur. So it has it's kind of evened itself out to a certain degree. Impacts on the storm of sufficient intensity located in exactly the wrong place have shown that disruptions can be extreme. So let's talk about Sandy, Harvey, Helene, makes that list now. They don't even necessarily have to be super strong as they come on shore, but they hit the wrong spot or if they move slow enough, they can be devastating. And as landfall and intensities match up with historical distributions, costs will be much greater due to growth and exposure, vulnerability, and property wealth. So you've already seen that in 2017, and it's going to keep happening. So basically it's pretty simple. You build more stuff near the coast, the hurricane has more targets to hit. So it is kind of way things are going. A landfall in areas of dense population and infrastructure increases the threat for widespread property damage and loss of life. And there is some evidence for a recent trend for storms to slow or stall near the North American coastal areas prior to landfall. And if that happens, it can lead to higher rainfall totals. Debbie's a good example of that, as it slowed down off the South Carolina coast. And a lot of rainfall occurred in the Carolinas as a result. So let's go into the forecast now. A little bit about what makes tropical development enhanced. Ocean temperatures have to be warmer than average. Vertical wind shear or wind changes with height are weaker than normal. So basically what that means is that you want the wind to be blowing in the same direction and about the same speed, way aloft at the jet stream level and closer to the surface. So that keeps the storms more organized. If we have different speeds or different directions, that can tilt storms and make them more disorganized, and most of the time it weakens them. And you also want large-scale rising air motion, so that tends to help things get going and keep things moving along. So if you have those three things together, you have the greatest risk of tropical development. And putting this on the map, if you take a stronger and wetter West African monsoon season, so every single year you're going to get the monsoon that forms there, and then it will spit out waves that get caught in the trade winds, and they come westward across the main development region, which is defined as the tropical Atlantic through the Caribbean. So if you have more waves that are stronger, and then they move through the favorable warm ocean with reduced wind shear environment, you're going to get more storms. However, if you have a weaker West African monsoon, and then you don't have warm water, and you have lots of shear, then it could be pretty quiet. So those are the types of things that we look at as we forecast individual systems, but we can also look at the seasonal trends, and that's what we're about to do. So what are the main seasonal drivers? Well, we spent most of the winter in La Nina, and we're emerging from that now, and we're going to have ENSO neutral that will occur for the late spring through the summer and through the tropical season. So even though you look at the water temperature anomalies in the tropical Pacific west of South America, note there are some light color yellows in there, so it might even be positive end of neutral, or at least a little while. But we are expecting it to not. We're expecting it to be in the neutral camp and not El Nino. The negative phase of the Pacific Decadal Oscillation, or the PDO, warm water in the North Pacific relative to the relative cooler water along the west coast of North America. So that's a negative phase. And then on the Atlantic side, we do have above normal North Atlantic Ocean temperatures, but are not nearly as warm as what they were in 2024. And the ENSO forecast through the rest of the year and into early 2026, most of the models, these are from modeling centers all across the world. The thick red line is the model average. So note the slight increase into the positive neutral section for most of the guidance through June and July, and then the slow decrease, I think, through the fall and into the winter season. So pretty good chance of ENSO neutral, but there are some models that want to sneak up to a weak El Nino. It is not impossible, 10-15% chance maybe, but ENSO neutral is by far favored overall. And then the slow cooling will occur, and there's more spread out there, so it's a little bit less confidence at this time. But we do think the water temperatures will be cooling as we go through the peak part of the hurricane season. And why does that matter? Well, the statistics say that La Nina and ENSO neutral are more favorable for storm development than El Nino. And note here, all El Nino since 1995, the average is 13 named storms, 5 hurricanes, and 3 major hurricanes. But if you compare that to neutral ENSO and La Nina, they are quite a bit more, 17 apiece, and then 8 and 9 respectively, and 4 major hurricanes. So if you have neutral ENSO and La Nina, those are more favorable than El Nino. So let's take a look at some analogs. First things first, though, we're going to take a look at some current sea surface temperature anomalies. And right now, you do have some warmer water in the MDR region and into the Caribbean, and especially into the Gulf. You do have also some warmer water off the coast of South America, and you have some cooler water from the Baja California region of Mexico all the way through the central tropical Pacific. And if we're going to compare that, look at the similarity to April 2012. Note that the cooler patches are in the same spots, a little bit cooler overall than what back then than it is now, but the features are about the same. It's the cooler patch from Cabo Verde Islands, just off of Africa. That's in there, a little bit warmer to the west of that. The warm Gulf, warm off the northeast coast. And then that cool patch from western North America to the central tropical Pacific. All those features are in place. So this is a pretty good analog from a sea surface temperature standpoint. And I thought it'd be good to highlight that because usually they don't look this good. So our analog average, and it's not the only one we use, we have several others, but note the 1991 to 2020 historical average, 14 named storms, 7 hurricanes, and 3 major hurricanes. And the 1995 neutral, ENSO neutral years, notice is higher than the historical average, 16.5, 7.9, and 3.6 respectively. And our 2025 analog package, which includes 2012, has 17.3 named storms, 8.2 hurricanes, and 3.5 major hurricanes. So it's near or slightly above the historical average and the ENSO neutral year output. So the analogs would suggest a slightly busier than normal season coming. And here are some individual analogs. We noted 2012, it's in the top left, and what actually happened. But we also have 01, 2011, 2021, 17, and 08. Here's kind of, you take a look at it and you notice a few things. A lot of storms that come westward and recurve up into the central Atlantic and then off to the east, and the storms that don't have much of an impact on the U.S. directly. Almost every one of our top analogs has that in common. But also in the Gulf, you can see some close-in development. So that's certainly a thing that we're going to have to keep an eye on. And then the other track, the ones that don't recurve, are shown to go through the northern Caribbean Sea and then in towards the southern Gulf, perhaps into Mexico. And there's not much there for Central America, so this may be a quiet year for them. Breaking this down into track density anomalies, note here, this is for the entire season, and you can see very clearly the recurve as you follow the orange line back towards the Lesser Antilles and then northward towards Bermuda. Clear signal for the recurve storms in there, and some of that could get somewhat close to the northeast and the Canadian Maritimes. So those two areas might have to watch. And then there's some close in development across the Eastern Gulf, and then there's a big reduced signal across the Southern Caribbean. I'm breaking it down by months and during the peak season of August, September, and October. In August, there's a pretty decent signal for some long track systems going through the Caribbean and then some close in development in the Gulf. You don't see as much from the recurving tracks just yet, but if we go into September, which is the busiest month usually of the year, a big signal for recurving storms during that time, and a lesser signal for close in development. And then we go into October. You note here there's a little bit of both. Usually this is the month where you stop getting the long track storms from the MDR and you get development in the Western Caribbean and into the Gulf. So that's what that's showing there. But even so, there's still some recurving potential there in October. Some tropical parameters. Note warmer Gulf, but cooler MDR temperatures that the CFS model is showing. And then other things, look at the shear forecast, and the blue is where below average shear is forecast from the CFS, and then the orange is where above average shear is forecast. Now note there's a lot of blue in the MDR and into the Southern Gulf. There's a little bit less in the Northern Gulf and off the Eastern Seaboard, and then there's a bit more in the Caribbean here. So wrapping this up together, water temperature should be a bit cooler than what happened in 2024, but still somewhat favorable. And the reduced shear is favorable for a little bit more of an active season. And it kind of plays along with the analogs pretty well. Now the ECMWF UK Met Super Blend rainfall anomalies from July through September. Note there's not a ton there. It looks a little quieter to start the season. But if you look at the Gulf, look at where it's a little bit wetter. There's that close in development potential highlighted from the model guidance. So that corroborates the analogs to a certain degree. But the model guidance does show it's not very impressive right now. It's less impressive than the analogs. And but again, this is July through September. It doesn't include October. So we could have a little bit of a slower start to the season. That's what this really could mean. The ECMWF name system forecast through October does show 16 storms overall, which is right about the average. It is forecasting several less than last year. So it is worth noting that the ECMWF failed to catch the 3 biggest years, but this year's not really looking to be that. But that is definitely worth noting because the red trace is what actually occurred, so you can see what the forecast is versus what actually happened. So summary real quick, the environment. ENSO neutral is favorable for tropical development, and analog years indicate slightly above average tropical activity can be anticipated. Water temperature should be cooler than 2024, but it's still above normal, so it's still favorable. And there's a lot of warm water that will be in the Gulf and off of the southeast U.S. coast. So this is somewhat favorable for development. Wind shear is forecast to be below normal by all guidance, which is also favorable for development. Model guidance is less optimistic on rainfall in the tropics than it was last year leading into the 2024 season. All that warm water near the coast could mean for some rapid intensification, and that's favored by the analogs as well. So all these signals strongly suggest a slightly above average season could unfold. So where could these storms end up going? So we'll take a look at some upper air patterns. And this is the lower landfall period for major hurricanes that we talked about. And this is the 500 millibar pattern. So this kind of gives you an idea of what the steering flow is like. And during that time, we had a trough of low pressure along the East Coast and a big ridge of high pressure off the Canadian Maritimes and up towards the Arctic and then across the western U.S. with a high pressure system in the central Atlantic. So you had a lot of storms that drew westward and then were able to be deflected northward into that recurve pattern. Think of the low pressure as a kind of a barrier as it picks storms up from the south and brings them north. And if you take a look at all the systems that occurred during that time, which is on the right, there were many, many recurve storms overall. So that trough steered a lot of storms out to sea. Now, hyperactive 2020 was a different story. Look how different the pattern was. The trough wasn't along the coast anymore. It was back towards the central part of the country, and the high pressure ridge was just off the Canadian Maritimes and towards the northeast. So that opened up a big window to bring storms westward through the Caribbean and into the Gulf. As soon as they got towards the Gulf, they were drawn northward by that trough. And then look at the tracks in 2020. Almost every single one of them drifted into that region. Very busy in the Gulf in the central and eastern Gulf during that time. There were a couple recurve tracks anyway, and which is very well possible. I mean, it's because the average height anomaly was that. It doesn't mean it will remain that. So compare that to what the analogs are showing this year, and doesn't that look a lot like that lower landfall period? Note the high pressure off the Canadian Maritimes, the trough along the coast, and the ridge in the western part of the country. So a lot of recurve patterns. Now the high pressure in the Canadian Maritimes could cause some of those recurves to get pretty close. So the Northeast US and the Canadian Maritimes might have a little bit more of an increased risk here and there. Most of the storms will probably be to the east of them, but we'll have to watch it slightly above average. And then you have the close-in development, and then the track that goes westward through the northern Caribbean towards Mexico. So let's wrap this up into an outlook. We're going to go with 18 named storms, 9 hurricanes, and 4 major hurricanes. Not much different from the analog and what the ECMWF was predicting. And we're going to, we're going to go along with it. Notice the recurve track with the slightly enhanced risk shape to the right. Coming up north of Bermuda, the Canadian Maritimes, and a lot of open water. We'll have to watch for that. And then slightly enhanced risk across northern Caribbean, and then the close-in development in the central and eastern Gulf towards Florida. Have to watch there. And then we're going to go below average risk across the southern Caribbean, Central America. Here are the Atlantic storm names this year. Hopefully we don't have to use all of them, and hopefully we don't have to retire any this year. We're hoping this year will not be quite as impactful as last year, but we'll have to see how it unfolds. So key messages. Pattern indicators are favorable for tropical development, but not as favorable as 2024 was. So it shouldn't be quite as impactful of a year. That doesn't mean it won't be, but the indicators are not as favorable. The analog patterns suggest that there is a higher risk of recurving storms this year. However, close-in development is possible, and there will be some risk of a rapid intensification of storms closer to the U.S. coast. The Northeast U.S. will have a higher chance than normal of an impact this year. The chances are never high, so even if we're going higher than normal doesn't mean it's going to happen. It's just we're going to have to keep a little bit closer eye on it this year than in recent years. Central America has a reduced risk of tropical impacts, and even a weaker tropical system, as we've seen, can have a significant impact if it strikes a highly vulnerable location. And with that, I'm going to pass it over to Steve, our fearless leader, who will talk about the summer and all those impacts. Thank you, Steve. Take it away.
All right, thank you very much, Nate, for taking us through the tropical portion of the forecast. Now we'll look at the non-tropical part of the forecast and kind of jump right in here to the temperature outlook for the upcoming summer season. You have the June to August map on the left side there, and then the month-by-month outlook from May through September on the right. And so pretty obvious that we are looking for a very hot summer across the plains and the Rockies in particular. Those areas look to see the strongest warm anomalies, not just for the average, but for most individual months as well. But notice that the East Coast itself is just near to slightly above average for the summer season, although warmer than average pretty much for all of May across the eastern US there. But notice for June onward, for the most part, near to just a little bit above average. So while we do have a lot of heat on the map, especially across the middle part of the country into the west, with the East Coast and parts of the Gulf Coast closer to average, That will reduce the overall U.S. population-weighted CDD totals just because those big population areas on the coast there won't be seeing the core of the stronger heat that the lower population areas of the plains and the Rockies will. But definitely overall, another warm summer for most of the country. Now, looking at some of the inputs here, on the left-hand side, you can see our analog composite. This is the same analog group of analog years that we used for our hurricane season forecast. And you can see that also favors a hotter than normal summer across much of the country, especially across the plains and the Rockies. And notice that the model composite on the bottom left side there is fairly similar in terms of the pattern, again, favoring the strongest heat across the plains and much of the interior west. So pretty good confidence there with both of those showing a very similar pattern, favoring the central and western heat. And also both of those favor just near to a little bit above average temperatures along the East Coast. Now, the hot scenario is essentially the same pattern that we have in our forecast, but just everyone's a little bit warmer. The cool scenario, though, would generally favor more rainfall across a lot of the eastern half of the country, helping to suppress temperatures to more seasonal levels. There's a strong correlation between soil moisture and temperatures across, especially the Midwest. And so if we do see May and early June end up a lot wetter than currently forecast across a lot of the Corn Belt and those surrounding areas, that will have an impact on tempering the heat during the middle of the summer season. So we'll have to watch the rainfall going forward here the next 6 to 8 weeks and see how that plays out, as that will have an impact on the balance of the summer season thereafter. Now, if you look at the CDD totals here on a population weighted basis, you can see the trends over the last 40 years or so on the left-hand side, both year by year, and then just having them all ranked. So notice that this year, while it is hotter than average, we are looking to be cooler than last year, but a little bit warmer than 2023. So kind of in between those 2 years, again, with the core of the heat across the plains and the Rockies, that is going to reduce the overall CDD totals from what they could otherwise be if that heat was centered a little bit farther eastward. So we'll have to kind of see if that does play out the way that we're currently expecting. Obviously, if we do see the heat end up a little bit farther east and more into the Midwest as opposed to the plains, that would certainly have a big impact on our CDD totals for the summer season. But again, overall hotter than average, just not as hot as last summer for the US as a whole. Now, looking at the rainfall outlook for the summer as a whole, as well as each individual month, much like the temperature outlook, the main factor that stands out here is the widespread dry conditions forecast across the middle part of the country. So not just very hot, but also very dry across the plains area into the northern Rockies, in the eastward into the western areas of the Great Lakes, most of the central and western Corn Belt, quite dry in the summer outlook right now. And again, with those areas forecast to be drier than average, that will tend to enhance the heat across those areas as well. So again, both of those tie together. And so if the rainfall does end up higher than forecast during May and early June, that will tend to kind of feed back and reduce the temperatures a little bit as we head into the summer or the middle part of the summer season. But for now, a lot of dryness across the middle part of the country, and with drought already in place in those areas, that will just lead to an increase in the drought as we go forward into the summer season. But notice on the East Coast, again, those areas there, wetter than average for the most part for most of the months of the summer season, and that will help to suppress temperatures. But with the extra moisture, you will tend to see a pattern where the overnight lows in those areas tend to be warmer than average, but the daytime highs with the extra clouds, the extra rain, will tend to be suppressed a little bit. So not as much on the extreme highs on the daytime side, but you could see a fairly persistent regime of warmer than average low temperatures for the eastern seaboard with the higher humidities coming in with that higher rainfall. Looking at the drought conditions and the expectations, already a lot of severe to extreme drought from the Southwest down into Texas, and pretty much widespread moderate to severe in some pockets of extreme drought across the plains up into the northern Rockies. And again, those areas are favored to be hot and dry as we head through the summer. So as you would expect, the map on the right shows drought conditions expanding in those areas going forward over the next several months. And that likely will continue to be the case. That map only goes through July, but if you were to extend that into August, you would expect to see even more expansion of drought as we head through the end of the summer season. Now, if you look at the wildfire risks associated with the hot and dry conditions for July here, you can see that much of the western U.S. from the northwest down into California will see enhanced fire risk. A lot of those areas We're not particularly wet this winter, and with the warmer than average conditions, especially across the Northern Rockies, that will favor overall a higher wildfire potential than usual. Also, above average fire risk across the south central portions of the country, Texas and Oklahoma. Again, drought is in place there. Hot and dry conditions forecast for the summer season. So we could see as the drought conditions basically worsen and expand across those areas during the summer. Things are actually a little bit wetter right now, as is typical in the spring, but as we do see the heat and the dry conditions kind of gradually take their toll on the soil moisture levels, we should see an enhanced fire risk in those areas as well. But not just below average rainfall, below average humidity as well across much of the plains and Rockies, but potentially also a little bit above average wind speeds across the northern tier of the country. So places like Montana could not just have dry conditions, but also some elevated winds, making the fire conditions potentially a little bit worse in those areas than would otherwise be the case. Now, looking at the wildfire outlook month by month from now all the way through the middle of the summer season, you can see we kind of see a northward shift in the fire potential with time across the western US, but a reduction in fire risk across the southwest into July. And that's the result of the monsoon kicking up during the middle part of the summer season. Now, as the monsoon pattern ramps up across the southwest during the summer, at the initial stage of that, we first start seeing those afternoon thunderstorms get going across the southwest with the severe to extreme drought currently in place. Those storms will produce some lightning that may actually start some forest fires in those areas. But then as the rainfall kind of gradually increases during the middle of the summer season, we should see the fire risk diminish across a lot of the Southwest as the rainfall totals kind of gradually increase over time. Now, severe weather has certainly been above average across a lot of the eastern half of the country. We've had some notable tornado outbreaks in many areas, and in fact, we're running well above average on our tornado count so far year to date. And so that has certainly been a notable feature of the early part of the spring. But we are looking to see likely a general reduction in severe weather across the central and southern US going forward. But nonetheless, certainly a very active spring so far. You can see the tornado totals on the left-hand side and the damaging winds on the right-hand side. So very, very active start to the severe weather season so far this year. Now going forward here, we kind of look at the patterns aloft to kind of get an indication of where severe weather will be more or less likely to occur during the late spring and during the summer months. The map on the left shows our expected for our current SST patterns. The map on the right is kind of the pattern that you typically see during the active years. And so while the overall pattern in terms of the SST anomalies is similar to what we see during those very active years, obviously we don't have the La Nina as strong as what it was. It's actually weakened quite a bit. And so that is one factor kind of working against the potential for a very active late spring and early summer across the southern half of the country in terms of severe weather. But nonetheless, some similarities still persist currently. Now, if we kind of look at those analog years in terms of jet stream winds, the blue areas indicate weaker winds than average, the yellow and the red stronger winds. And typically you need to have those stronger winds aloft to help produce those severe and tornadic thunderstorms. And with below average wind speeds expected as we go into the summer season here across a lot of the Southwest plains and up towards the Great Lakes, that kind of is a good indication that we should see a reduction in the risk for severe weather across that area of the country. Now, looking month by month here, if we look at the month of May, while the pattern across the Pacific is generally similar to what we typically see during busy years, it's quite a bit different across North America, as you can see if you compare our analog composite on the top left to the composite for busy years on the bottom left. Some notable differences overall, essentially more widespread areas of the country seeing below average winds aloft, again, reducing the risk for the more severe types of storms that we typically see during the month of May. And that pattern really continues as we go through June into July as well. So again, a lot of areas across the plains into the Midwest with below average wind speeds aloft, above average though across the Northwest into the Northern Rockies. We could see an enhanced risk of severe weather up in like the Dakotas, up into Montana, maybe parts of Minnesota, but reduced risk overall across a lot of the southern half of the US during June. And pretty much the same story in July, above average wind speeds along the Canadian border expected, and below average central and southern areas of the country aloft. So those rotating tornadic supercells probably going to be more likely to occur along the Canadian border, again, the Dakotas to Minnesota into Wisconsin, potentially upper Michigan, but reduced risk across Kansas, eastward to Illinois, and points southward. So kind of summarizing the summer season here, kind of going from west to east along the west coast, warmer than average, but not a particularly hot summer relative to some recent years. A lot of the core of the heat forecast to stay farther inland across the Rockies and then eastward across the plains. So we'll see some hot periods for sure. And overall, with the below average rainfall, and then just generally the persistent warm conditions, we should still see overall, an increase in the drought and again enhanced fire risk, especially across the Northwest as we head through the summer season. Across the Southwest, again, very hot early in the summer, but as that monsoon activity picks up and likely stays more active than usual during the middle and latter part of the summer season, that should reduce the fire risks. Also increase the potential for more localized flooding across, areas that are flood prone as we head through July into August. Farther north, though, staying drier across the northern half of the Rockies and staying drier than average across the plains. That will enhance the heat in those areas. And so definitely a hot and dry summer forecast for that part of the country. Farther east, though, again, the trend is for more rainfall across the eastern U.S. this summer season. The south central U.S. and towards Texas and in those areas there, we'll also see some increase potentially in rainfall as the summer season progresses, but for the most part, the very extreme drought in place across a lot of Texas right now will certainly be a factor for enhancing heat early in the summer. If we do see some rain pick up later in the summer, that may help to reduce the heat potential for the tail end of the season, but certainly early on still quite hot. But for the East Coast, again, warm, humid, lots of rain, but for the most part, not as many of the extreme heat days. Now, looking at the renewable side of things, as you would expect with the hot, dry conditions across the central US, that's going to be associated with a lot of sunshine. And so those areas will be seeing above average sun and above average solar generation potential. Wind speeds, though, for the most part, near average for the summer as a whole. There'll be month-to-month variability, but for the whole summer, coming in pretty close to average as it looks right now. But there is a slight increased risk for above average winds across the plains and northern Rockies. So if we do see things kind of skew one way or the other, the odds kind of favor winds being a little bit above average in those areas instead of below. So kind of summarizing the summer season here, again, a moderately hot summer on a population weighted CDD basis. Certainly it's going to be quite high in terms of the area weighted average for the US with all the heat forecast. But again, with the heat mostly across the plains and the Rockies and the lower population areas, it shouldn't come in as hot as last year on a CDD basis. Again, the Northwest and the Northern Plains areas could be seeing the greatest heat, the greatest wildfire risks. The East Coast, certainly, the main factor there will be potentially a lot of rainfall at times this summer season. So, occasionally some flooding risks and a lot of humidity, but generally speaking, not as many of the extreme heat days. And also across the Southwest with the monsoon likely coming in stronger than average this year, we should see a lot more rainfall in July and August in those areas. So localized flooding in those areas and some reduction in drought as time goes on through the summer season. And with the West Coast, again, warmer than average, but not as much of the extreme heat right along the coast. So LA, San Francisco, those areas in there, warm, but not extremely hot. But farther inland, certainly a lot of heat once you get into the deserts, up into the Great Basin, interior Northwest areas. And so those areas in there, again, favored to see a lot more wildfire risk this summer season. Now, looking sector by sector in terms of the utility side, obviously the main factor will be the widespread heat across the country, especially in the central US, which will certainly create high demand for electricity for cooling the summer season. The severe storms that we've been seeing across the south central US, that should shift northward during the coming weeks. And so those areas likely seeing a reduced risk for severe weather once we get past the middle of May. But we should see that risk shift northward into the upper Midwest, northern plains areas, so the Dakotas, eastward to the northern Great Lakes. Those areas will likely see above average severe weather later in May into June. And so those will be the areas to focus on for potentially more power outages and things like that from severe storms later in the spring. Obviously, any tropical system could produce all types of problems, in terms of, flooding, damaging winds, causing all kinds of impacts wherever they may occur. So the entire Gulf Coast, especially eastern areas, will have to be watched for, tropical landfall at some point during the summer season. Again, with the hot, dry conditions, above average solar, slightly above average wind across a lot of the central US the summer season. But the East Coast, again, a lot of humidity, so not the extreme heat, but the humidity will keep those overnight temperatures kind of warm, and that may still result in a little bit more demand than you would otherwise expect on the power side. Now, looking at aviation, again, the northern tier of the country will be the area to watch for the greatest aviation impacts in terms of severe weather, also stronger winds aloft in those areas as well. So a lot of those typical big thunderstorm complexes that get going in the afternoon and evening hours will be kind of tracking across those areas for much of the summer season. And so there may be a number of days where we have flights delayed or having to route around those big storm complexes and causing issues in those areas, and more turbulence, just stronger winds aloft in those areas as well. The East Coast, though, could actually see, especially across the Northeast, some foggy days here and there with the pattern there that we're currently expecting. Now, on the public safety side, obviously a lot of heat, a lot of humidity for different parts of the country. So the plains, just a lot of extreme temperatures will produce a lot of safety risks for outdoor events. And the East Coast, not as hot, but the high humidity can still have a real big impact on outdoor events as well. So that will be a concern there. Now, obviously, lightning risks from thunderstorms will be a big concern across northern portions of the central U.S. During the next couple of months as well. And obviously, with the expected increase in rainfall and thunderstorms along the East Coast, lightning and just rainfall in general will have probably a large impact on all types of outdoor events this summer season. Of course, tropical systems, wherever they occur, will be a major impact as usual. In terms of offshore impacts, again, we do have that potential to see tropical systems developing close into the U.S. in the Gulf. And so as we look at those storms developing and tracking towards the northern Gulf Coast, potentially impacting ports, but impacting offshore production, we'll have to watch for that as we go forward in time here during the course of the later summer into the early fall months. But generally speaking, that will be a concern going forward. The other impact will actually be the higher potential for recurving storms well off the East Coast. That will have maybe not direct impacts on the East Coast, but it will have shipping impacts for between North America and Europe. We will see likely a above average number of storms tracking, kind of like towards Bermuda and up into the northern Atlantic, impacting shipping at times, especially from August into October. So in general here, to summarize one last time, we do see, again, a very hot summer for the middle part of the country, a lot of drought expansion in those areas with the dry conditions, but wetter than average along the East Coast, a little bit more seasonal. And again, that heightened risk for tropical activity in the Eastern Gulf, as well as much of the Atlantic Basin. And so with that, Nate, have we had any questions come in that we can take a stab at answering?
Yes, Steve. Thanks for the great information. And yes, some questions have come in. First one up is, why has the Atlantic cooled so dramatically since the record levels in 2024? I can take that. 2024 had a strong El Nino to start the year, but it did weaken rather quickly, and some cooler temperatures did develop in the eastern tropical Pacific pretty quickly. So some feedback loops, a lot of warmer water was able to pile up in the MDR region of the Atlantic Ocean, and part of that is because there were reduced trade winds across the tropical Atlantic, and that allowed some of that warmth to be able to be shuttled further east. The difference between that and this year is we've had La Nina. La Nina occurred during the winter, but as the winter went on, especially as we come into the spring, a lot of warmer water developed in the eastern tropical Pacific, especially right along the South American coastline, and that caused some upward motion in there. And once that happens, it created a feedback loop where enhanced trade winds occurred across the Atlantic Ocean, and that allowed for a lot of cooling in the MDR. So 2024, going into the season, most of the warmth was in the south, but these impacts have wiped out a lot of that warmth. 2024 in the central and northern Atlantic versus now are not that much different. So eventually everything became a bit warmer as we went through the late spring and into the summer in the northern Atlantic, but we're expecting that to happen again this year, and it won't be too much different. Where a lot of the cooling will occur will be in that tropical Atlantic, the main development region, and that is because of all that warmth that occurred in the eastern tropical Pacific. And let's see here. Next question that came in. Do we have a forecast for gas-weighted HDDs during the and does that prepare or compare to year over year versus average? Not exactly what you're expecting too many of those during the summer, but do do you think there will? How do you think HDDs will compare versus last year, Steve? Let's keep the question simple.
All right. Yeah, for the summer season, obviously not a lot of HDDs. I'm not sure if they're looking maybe ahead towards the fall season. Um, at this point, obviously we're kind of focused more on the summer, but we do expect the warmer pattern to persist into the early part of the fall season. So that would in general reduce the HDD totals going forward, as we look forward in time into the, say September to November period. So at this point, lower than average is the current expectation for at least the first half of the fall season, based on that. But obviously, not a whole lot of HDDs during the summer months.
Yeah, Steve, the question was corrected to be CDDs. So can you
Oh,
go back to
okay.
the slide for the comparison to last year? If we do, or do we have that on there? If not, I'll pull that up real quick.
Too far. There we go. There's the CDD totals. So actually, if we were to look at the, we don't have gas weighted CDDs on here. It's actually going to be fairly similar if you were to compare gas weighted to population weighted CDDs, since a lot of the gas demand in the summer is coming from natural gas power plants, and that will tend to be focused more in the population areas anyway. And they're fairly evenly distributed compared to past years. So overall, the total will be similar. There'd be some minor differences, but obviously we would still expect it to be less than last year on a gas weighted basis versus a population weighted basis, and probably still higher than 2023. Generally speaking, you don't have a dramatic difference on the CDD side of things between gas and population weighted. You see a larger difference on the heating degree day side between gas and population weighted, just because of variations in how heating is done in different parts of the country.
That's a good point. Yeah, thank you, Steve. Yeah, exact numbers have to be looked up. We don't. Yeah, you usually don't deal with the gas weighted side on a presentation like this anyway. So you can look up the totals later and email the question to you, or email the answer to you after the presentation. That would be easy to do. Next question. Been some stuff in the news in recent years about the ratios. There've been a lot that's been popping up in the Midwest recently. They've been very highly impactful to a lot of things, from agriculture to utilities to pretty much everybody where they go through. So, do you think we're gonna have a better chance than normal of having one of those type of events this year?
Yeah, I can answer that. I mean, that's certainly a possibility with this pattern. If we do see, a lot of times when we see those types of events, we have a strong ridge of high pressure loft across the middle part of the country, and you kind of get that northwest to southeast flow across the Midwest, and that will likely be the case for a lot of the summer. Kind of, you get that ring of fire pattern across the middle part of the country, and you tend to get those storm complexes that form maybe over the Dakotas or Minnesota, something like that, and then dive southeastward across the Midwest. And that will be the pattern that we'll likely see at times this year, as we head into June, especially. And so that will certainly be a risk. Obviously, the extreme events that we've seen at times in recent years, it's always kind of hard to predict whether you'll see something like that. There's just based on what happens, during each individual, weather day and what the pattern is like. But certainly across the Great Lakes into perhaps western areas of the Northeast, that upper level pattern will likely sort of support that type of event happening this year. But whether we see anything extreme is kind of hard to say at this point. But that would be the area that it would happen if we did see it again this year.
Yeah, I mean that makes a lot of sense. I would 100% agree with that. We'll have to keep our eye out for that kind of thing. Even though we're talking a lot about dryness in the central part of the country, it doesn't take much to change that in the way the ridge pattern's set up. It's primed for at least a better than average chance. So we will see how that goes. Definitely got to keep our eye out. I think we're getting close to the top of the hour. It's 12:59 Eastern, 11:59 Central. So I think I'm going to pass this back over to Andrea. She can close us out.
Thank you, Nate and Stephen, for a great presentation. Like I said at the beginning, we have recorded this webinar and we will be sending out the webinar to everybody who's registered within the next few days, probably by early next week. And I want to thank you all for your attention and have a great rest of your day. Thank you.